How does ReLU work in neural networks? Imagine a neural network trying to learn from data, like recognizing images or understanding language. To do this, it needs to decide which signals to pass along and which to ignore. That's where activation functions come in. One of the most popular is called ReLU, which stands for Rectified Linear Unit. ReLU is simple but powerful. It takes an input value and checks if it is positive or negative. If the input is greater than 0, ReLU outputs the same value. If it is less than or equal to 0, it outputs 0. So, the function can be written as the output equals the maximum of 0 and the input. This might sound straightforward, but it plays a big role in how neural networks learn. When a neural network processes data, it computes a weighted sum of inputs at each neuron. ReLU then transforms that sum into an output that can be passed to the next layer. This transformation helps the network learn complex, nonlinear patterns. One of the main advantages of ReLU is that it helps avoid a problem called the vanishing gradient. Older activation functions like sigmoid or hyperbolic tangent tend to squash the output into a small range, which makes the gradients during learning very tiny. Tiny gradients slow down or stop the learning process. ReLU, on the other hand, has a gradient of 1/4 positive inputs, keeping the learning signals strong and allowing the network to train faster. ReLU is also very quick to compute because it only requires a simple comparison operation. It checks if the input is above 0 and outputs either the input or 0. This efficiency makes it ideal for training large neural networks used in image recognition, natural language processing, and even in AI tools like ChatGPT, DALL-E, and Midjourney. However, ReLU isn't perfect. Sometimes neurons can become inactive if they keep outputting 0, which is called the dead neuron problem. To fix this, variants like leaky ReLU and parametric ReLU were created. These allow a small, non-zero gradient for negative inputs, keeping neurons active and learning. Overall, ReLU's simplicity, speed, and ability to help deep networks learn make it a key part of modern AI systems. It helps neural networks understand and generate complex data, powering many of the AI tools we use today. Knowing how ReLU works gives us a clearer picture of how AI models process information behind the scenes.